Hey. Have you ever been arguing about something that you feel extremely confident about, only to find out that you were wrong? We can only argue for what we know. Or I should say, we should. But what happens when science proves a hypothesis? Or better yet, what happens when science proves a hypothesis wrong? Or even better yet, what about both? Two men, both right and wrong. Harlow Shapley and Heber Curtis. The Great Debate. In April of 1920, in the United States National Museum in Washington, D.C., two impeccable scientists, one from Nashville, Tennessee, and the other from Muskegon, Michigan, hit it off in a collaborative heated debate on something that no one knew better about at the time. You see, Shapley just believed that these things that we would keep seeing in our night sky were just nebulae, and that they were laying on the outskirts of the Milky Way galaxy. While Curtis believed that these things we were seeing were actually independent galaxies on their own. Imagine you're looking far off in the distance, and you think you're seeing someone sitting on a chair. But then you realize that the person was actually a lot closer to your perspective, and the chair was really far away. It was just really big. Now, this is an example of an optical illusion, and it's not a new concept that something with more distance can make everything seem small. But the things that once controlled me can't get to me at all. Sorry. So at a certain time in history, looking up at our night sky, it's not at all obvious what things could necessarily be without being able to measure the distance of the thing that we're looking at. These little clouds of gas and dust, aka nebulae, would be a lot closer given that it's just these clouds of gas and dust. Granted, still really big and they can still hold their own respective stars, but compared to what Curtis thought, having these things rather than clouds of gas and dust be independent galaxies, each also with their own 100 to 200 billion planetary systems. We're talking about two entirely different things here. So it's kind of apparent why they were so passionate about their own respective sides. So who was right? Now, I will say this. If we compare this to Rocky versus Apollo Creed in Rocky 2, and Curtis is Rocky, then Curtis takes the cake. This is because the major confusion for astronomers for decades was, are those little fuzzy spirals just small clouds inside of our Milky Way, or are they really distant galaxies? And yes, Curtis was right. Those fuzzy spirals are indeed distant galaxies that we can see in our night sky. Now, of course, distant galaxies exist outside of our own Milky Way, but how do we tell them apart? And how do we know today that Curtis was right? Well, there are two main methods that we can really use to know that these things in our night sky really are far away and are really big. This includes type 1a supernova and redshifting. A type 1a supernova is an explosion that happens at a point of a star's life. I go into a lot more depth in that in my star cycle video, but here we'll talk about why type 1a supernovas are so crucial to map out the universe. So they always explode at roughly the same mass. This means that they nearly have the same absolute luminosity, aka intrinsic brightness. Because of this, we know that because they are 5 billion times brighter than the sun, that we can see them from billions of light years away. Now, redshifting is not a distance measurement by itself, but more of a distance indicator. It can tell us how fast a galaxy is moving away from us, because the wavelengths become longer and more red, which increases with its distance. Hubble's law. This literally just means that if we measure redshift, we can get a velocity. And if we measure type 1a supernova, we can get a distance. So these two methods combined together, we can create a Hubble's diagram, which shows the universe expanding. This completely solidifies that in the grand scheme of astronomy, the Milky Way is not that big. When zooming out all the way to the Laniakea supercluster, and that these things in our sky really can be other galaxies because there are billions and billions of them in the universe. Because of these methods, we were able to figure out that Curtis was right, that these spiral nebulae we see are not bound to the Milky Way, and that they are galaxies, and that even the closest galaxies to Milky Way, like Andromeda, are far too far to be inside the Milky Way by any means. Now, I did say earlier that both were wrong technically, and that's just because of some points that they did bring up within the debate. Although right for all the main parts, Curtis did believe that we were at the center of our Milky Way. And contrary to this, Shapley thought that we were near the edge. Although wrong about thinking that these galaxies were clusters of gas, and thinking that the Milky Way was special for some reason, he was right that our solar system is positioned near the edge of the Milky Way rather than the center. Alright, well, we learned how it is that we can know how far away things are in our sky. And we also learned that just like Rocky, Curtis is the GOAT. In all real, I had a lot of fun researching this and putting this together, so thanks for your time, and like always, I'll see you in the next one. Good job, Curtis. Good job. Nice try.